Okay, in this example, we're going to take a look at lesson 7, equilibrium values. And so this example is one that you should see fairly similar to something you're going to see in WebAssign, because we start out with a difference equation. So the difference equation looks like this: P sub n minus P sub n minus 1 is equal to 0.5 P sub n minus 1 minus 10. Right? And it's a difference equation because if you look at the left-hand side, we're looking at the difference between two successive terms. So what is the difference between P1 and P0? But when we're calculating equilibrium values, we want to look at the general form of a recursion equation, which looks like P sub n is equal to A times P sub n minus 1 plus D. That's the form we want this in. And so if we're going to take our difference equation and manipulate it so that we can get back to our recursion equation, all we have to do is add P sub n minus 1 to both sides. Right? And so if we add P sub n minus 1 to both sides, now we've isolated P sub n on the left-hand side of the equation. We have 0.5 P sub n minus 1 minus 10 plus P sub n minus 1, right? And so we've got like terms here on the right-hand side. I can combine those so that this says P sub n is equal to 1.5 P sub n minus 1 minus 10. Great, so I've got my general form of the recursion equation. I know that A is equal to 1.5, D is equal to negative 10. I also know that the formula reference card has an equation on there for the equilibrium value that says that P star, my equilibrium value, is equal to D over 1 minus A. Okay, great. So now I can substitute my values in. I can say that P star is equal to negative 10 divided by 1 minus 1.5. So that's negative 10 divided by negative 0.5, which equals 20. So now I've found my equilibrium value. But usually finding the equilibrium value isn't going to be enough. So not only do we have to find these, we have to classify them. And so what you should hear is this acronym EARN. And so we tell you guys that to remember this acronym, which stands for equilibrium values, or EVs, attract, repel, or neither. And so one way that we can classify our equilibrium values is to iterate a few steps and see if we're moving towards our equilibrium value or moving away from our equilibrium value. So if we're going to do that, let's pick some arbitrary initial condition to go along with our recursion equation. So we've got P sub n is equal to 1.5 P sub n minus 1 minus 10, and we're going to say that P naught is going to be equal to 50, right? And so that means that P1 is equal to 1.5 times 50 minus 10, which equals 65. And P2 is equal to 1.5 times 65 minus 10, which equals 87.5. And so I'll do one more. P3 is equal to 1.5 times 87.5 minus 10, which equals 121.25. Great. And so we can tell just from looking at this, if our equilibrium value is 20, every successive step is getting further away, which tells us that this equilibrium value is repelling. And graphically what that looks like, if we plot n over here and P sub n on our vertical axis, I'm going to draw our equilibrium value at 20 right here. It's 20. We started out up here at 50, so this is 50. The next step, when n was equal to 1, we were at 65. The next step after that, we're at 87.5, and then 121. So we can see that we're clearly moving away from the equilibrium value, and it makes sense that the system is repelling. So now we've not only found the equilibrium value, but we can classify it using that acronym and a few steps of iteration.